Okay, now let's talk about the next kind of problems on the review. And I'm talking about starting at problem 28 and going from 28 until like 34. And this is where we have sort of two functions at the same time. We have a trig function and then an inverse trig function. And for these, they're the same type. In other words, sine of the inverse sine or the inverse sine of the sine. So for instance, problem 28, just to give you an example, we're trying to take the sine of the inverse sine of 1/2. Now sometimes there actually are some rules that if the rules apply, make these problems very easy to solve. First of all, there are two kinds. First, we have the sine of the inverse sine of 1/2, but then later on you see there's a problem where you take the inverse sine first. So you have the inverse sine of the sine of pi over 4. We would need to be able to solve both of these kinds of problems. The first one, you take the sine function first and then the inverse sine function's inside. But then at other times, you have the inverse sine function first and then the sine function is inside. Now, under certain conditions, these problems become very easy to solve. Because what happens when this is true, that's why sometimes these are called cancellation rules, because what happens is, it's like the sine and the inverse sine sort of negate or cancel each other out, and the answer is just what you start with, 1/2. Or for this one, if the cancellation rule applies, the inverse sine and the sine sort of cancel each other out, and the answer is just pi over 4. So when that's true, these problems are very easy to solve. But we have to understand the conditions by which these cancellation rules apply. So let's first look at the sines, and here's what's important. And this will not be given to you on the test, so you have to memorize it. This cancellation rule applies. In other words, the sine of the inverse sine of x equals x if the starting value of x is between -1 and 1. So in other words, if I look at the first problem up here, I'm asking myself, well, does this cancellation rule apply? Well, the condition is if x is between -1 and 1. If what I have in here is between -1 and 1. Well, it is. So yes, it applies, and I can just very easily and quickly say that's going to be 1/2. What happens if I'm given a problem like this? The sine of the inverse sine of 2. Well, my rule says if the thing inside the inverse sine is between -1 and 1, then I can use this cancellation rule. But in this case, it is not between -1 and 1. And now I have to think about it. And in this case, if I just look at this inverse sine function, I'm trying to take the inverse sine of 2, which I know is going to be an angle. So let's think about this as an inverse sine problem. So I can ask myself, let's go find an angle theta that when I take the inverse sine of it, it equals 2. And then hopefully you quickly realize that whenever you take the sine of any kind of angle, the answer is always going to be between -1 and 1. There is no angle out there that's going to give me a sine of 2. So in this case, there's actually no solution. This inverse sine of 2 is impossible. So I just stop and say, there is no solution. Now, let's look at the flip side. Let's look at now what happens when we take the inverse sine first, and then the sine inside. Now here, we also have a cancellation rule, and it applies in that this thing will equal x. Now in this case, it's going to equal x if my x is between negative pi over 2 and pi over 2. So when we're given a problem where we have the inverse sine of the sine, I need to go look at what's inside the sine here. And this right here is going to be an angle. And if it's between negative pi over 2 and pi over 2, then it's one of these cancellation rules. So for instance, looks like problem 31 is an example I want to do. I'm looking at the inverse sine of the sine of pi over 4. So I go check what's in my sine, and I see that it is within the allowed range for this cancellation function to work. Because of that, the inverse sine of the sine cancels out, and I'm left with pi over 4. However, let's do another problem. I'm now looking at the inverse sine of the sine of 3 pi over 4. I hope my cancellation rule works, because then it's very easy. So I check, but I realize cancellation only works if this angle in my sine is between negative pi over 2 and pi over 2. And in fact, it is not. This is outside this. So I cannot say this simply equals 3 pi over 4. That would not be correct. Now some of you might think, oh, well this is maybe just like up here where you say no solution. And actually that's not correct either. I can actually get an answer to this, and here's what we have to do. Basically, I go in here and I evaluate it first inside the parentheses first. What is the sine of 3 pi over 4? Think about your unit circle, and you go to 3 pi over 4. It's over there in the second quadrant. And you realize the sine of 3 pi over 4 is square root of 2 over 2. So now the problem becomes the inverse sine of square root of 2 over 2. So now I have an inverse sine function, so I say to myself, let me go find an angle that when I take the sine of that angle, it equals square root of 2 over 2. And I, in my mind, am realizing now that I'm taking an inverse sine function, I have the limitation that the angle I come up with has to be between negative pi over 2 and pi over 2. We just talked about inverse trig functions. You can't just give any answer. It has to be within a certain interval. So when I think about my unit circle, and I say what angle gives me, where I take the sine of the angle square root 2 over 2, it's actually right here. There's actually two angles, but this angle is not allowed. This angle is pi over 4. So I want you to see now, the inverse sine of the sine of 3 pi over 4 is not 3 pi over 4. I can't use the cancellation rule, but instead it actually equals pi over 4. So you notice these things are not the same. Maybe you didn't see this. So once again, when I did the inverse sine of the sine of 3 pi over 4, I cannot just automatically say the answer is 3 pi over 4, because this angle is not allowed. But I can go ahead and figure out an answer to this. I figured out the sine of 3 pi over 4 is square root 2 over 2. So then I say, so what's the inverse sine of square root 2 over 2? And lo and behold, it's actually pi over 4. So these cancellation rules, you have them for sine and for cosine and tangent. If you meet the requirements, they're great because they make it very simple. But sometimes you don't meet the requirements, and then you have to figure out what to do from there. Let me pause now, and I'll do a couple more in the next video.